So after we look at systems of linear equations, so lines, we bump it up we look at systems in 3 variables. And so 3 variables means we're looking at x, y, and z. So as an example, this one's going to be much bigger. We might see something that looks like x minus 1/3 y plus 1/2 z equals 1, and then y minus 1/2 z equals 4, and then finally z equals -1. And in a system of equations where there are 3 variables, we're not looking where 2 lines would intersect each other, but what we're looking at is 3 planes, because there's 3 equations, where 3 planes would intersect each other. So wherever you are, I'm assuming you're inside, but even if you're outside, what I want you to do is look at the floor and 2 walls. So if you look at the floor and you look at 2 walls, notice where the 3 intersect each other. Okay, the 2 walls intersect each other in a line, but then if you look at that bottom corner, where they intersect with the floor is that little point in that bottom corner. Use the ceiling if you want. You've got your 2 walls and your ceiling, and they intersect in a point. It's just that now instead of being in 2 dimensions, we're going to be in 3 dimensions. So when it comes to solving these guys, they get a little bit bigger and uglier. And again, in order to get to this point, you probably have done solving systems in 3 variables before. You probably have done this. So what we're really going to focus on is making this Gaussian. So the Gaussian elimination is a particular method that is not just kind of do whatever you want. It's a little bit more formal than that. And this first example is a really good example of the start to Gaussian elimination. So notice how the top equation has x, y, and z in it. The second equation is missing the x. It's got y and z, meaning the x was eliminated. And then notice that the third equation only has z, meaning the y was eliminated. So in the Gaussian elimination, the way that we try to do it is eliminate the x, eliminate the y, and then you won't ever eliminate the z, but eliminate the x first and then the y. And that might not be the easiest way to do it. Like when you look at a system, you might go, oh, I want to eliminate the z's or something. But in the long run, this is the better way to go about it. Okay, so it's it's not exactly perfect, but as we move on in this chapter, it's hopefully going to make a little bit more sense. And once we get to using our calculator a little more, it will definitely start making more sense. But if you wanted to solve this guy that's already in this what we call triangular form, because look at what happens here. If you draw a line like that, oops, my pen stopped working. Do you see how instead of being a rectangle, because we've already eliminated variables, we've actually got kind of a triangular form. Okay, so keep that word triangular in there. But what we could do is we can take z, which we already know is -1, plug it into the next one. So we have y minus 1/2 times -1 equals 4. So we have y plus 1/2 equals 4. So 4 is 8/2, and when we subtract 1/2, we'll have 7/2. I don't know why they started us with this ugly one, but that's okay. We can deal with fractions. All right, and then we're going to go with this guy and this guy up to the top one. So we're going to say x minus 1/3 times 7/2 plus 1/2 times -1 is equal to 1. So we have x and we have minus 7/6, right? And this is also going to be a minus 1/2, or I could write it as 12/6, right? So if this is a minus 1/2 and I wanted to write it in 6th, and we could actually write this guy in 6th as well. Write everything in 6th so that we've got the nice fractions going on. So we'll have x minus 19/6 equals 6/6. So when we add, we'll have x equals 25/6. Now, certainly not a nice problem, but that's just the way it works, okay? So if we were gonna write this one as a point, it's gonna be x, y, but then it's gonna be followed by the z. So this is the way a point looks in 3 dimensions. So we're gonna go 25/6, 7/2, -1. And when you have 3 equations going on, especially if they have fractions in them, it's a pretty good bet that the answers are going to be ugly. Now the nice thing about this is if we use this method long enough, we'll let the computer, or sorry, not the computer, the calculator do the ugly parts for us. Okay, so let's look at another one. And we'll try to work through this the way that they want us to. Okay. So we've got the system 3x minus y plus z equals 3. And then the next one is 2x minus 4y plus 3z equals 16. And then the third one is x minus y plus z equals 5. Okay, so the idea here is that we're going to try to eliminate x first, then we're going to eliminate y, then we're going to be left with z. Okay, so we'll see if we can get that done. The other thing that they do here is they actually kind of tell you what it is that you're going to do. So if we call each equation, like if we call this one E1, E2, and E3, okay, equation 1, equation 2, equation 3. If we want to eliminate x, we might take equation 1 and equation 3. Now the problem is, if we combine them right now, the x is not going anywhere, is it? So if we combine them right now, we're kind of out of luck. So we need to multiply this guy by a -3. So what we do is we write it like this, and this I know is going to seem weird, but we say E1 minus, I guess I wrote it like that, minus 3 E3s. And that's going to be our new E1. Okay, so we're just, no, let's make that our new E3. Sorry, I forgot we're eliminating stuff here. So what we're saying, and this can be our scratch work here, so we're going to go 3x minus y plus z equals 3. And underneath it, I'm going to multiply this guy by -3. So it's going to be -3x plus 3y minus 3z. Make sure you be careful with the negative. And then minus 15. So when we combine, those guys are going to go away, right? These guys are going to leave us 2y. And this is going to leave us minus 2z. And that's going to leave us minus 12. So what we can do here now is we're going to rewrite this as 3x minus y plus z equals 3. Then the middle guy we didn't touch at all. 2x minus 4y plus 3z equals 16. And then in this last place, we're going to put our new equation, which is 2y minus 2z equals -12. Okay, so we're trying to get to that triangular shape, which is a royal pain in the butt, okay? And it's not exactly the way you'd want to do it, but we're kind of working towards something, so go with me on this one. Now, we need to still eliminate an x, because there shouldn't be any value here as well. So we're now going to deal with these two guys and try to eliminate the x again. The only issue is, again, that they don't match. So this is a 3 and that's a 2. So we need to have we need to go to 6 and we need one of them to be negative. So if I multiply negative 2 times E1 plus 3 times E2, that's going to be my new E2. Okay. So again, scratch work underneath here. We're going to take negative 2 times this. So negative 6x plus 2y minus 2z equals negative 6, right? This one is going to be positive 6x minus 12y multiplied by 3, so plus 9z, and then multiplied by 3, so 16 times 3, 18, 48. Okay. Not always going to be pretty. Okay. So now we have negative 10y, because those guys are going away. Here we're going to have plus 7z, and here we're going to have 42. Okay. Now I'm going to eliminate our scratch work because I need more of the board. So we now have the top guy has not changed. 3x minus y, plus z equals 3. Our new middle one is going to be minus 10y plus 7z equals 42, which is not all that pretty. And our bottom guy, which we didn't touch, is 2y minus 2z equals negative 12. Okay, so you see how we've eliminated 2 places now. All right.